Hi there, welcome back to Pretty Much False. Today in this video we are going to be looking at logic gates. Let's get into it. So first we'll talk about statements. So true is a statement that equals 1 in binary, and electrically that'd be 2.5 volts or more, just basically a voltage. False, another statement, 0 in binary and 2.5 volts or less. I guess some chips below a certain voltage, then they'll classify that as 0 or false. So, alright, let's move on. The first gate we'll talk about is NOT, or invert. Here's the diagram. And what this does is it will invert the incoming signal. So let's say you apply a 0 this end, or basically 0 volts. On the output, you'll get a voltage. If you apply a voltage this end, then you'll get 0 volts on this side. So what it does is basically inverts the incoming signal. Next we'll talk about the AND gate. So it's a little bit different. It has 3 terminals, as you can see. So the one is A, next is B, and this is the output terminal. Alright, so if input A is 0, if input B is 0, the output is 0. If input A is 0, input B is 1, the output is still 0. If input A is 1, if input B is 0, the output is still 0. This is called the AND gate because when input A is 1, input B is 1, the output will be 1. Next gate we're going to talk about is the NAND gate. So what it is it's an AND gate, only basically converted. So NOT and AND gate combined. So we'll go through. If input A is 0, input B is 0, the output will be 1. If input A is 0, input B is 1, the output will be 1. If input A is 1, input B is 0, the output will be 1. If input A is 1, input B is 1, the output will be 0. So basically, just the AND and a NOT gate combined to make a NAND gate. This gate we're going to be talking about is the OR gate. So here's the symbol. Kind of similar to that of the AND gate, only has like a bit more curve there. So we'll do the same thing as the AND gate. So if input A is 0, input B is 0, output will be 0. If input A is 0, input B is 1, the output will be 1. If input A is 1, input B is 0, the output will be 1. If input A is 1, input B is 1, output will be 1. Next gate we're going to talk about is the NOR gate. It's basically a NOT and an OR gate combined into a NOR gate. So we'll go through the inputs and outputs. So if input A is 0, input B is 0, the output will be 1. If input A is 0, input B is 1, the output will be 0. If input A is 1, input B is 0, the output will be 0. If input A is 1, input B is 1, the output will be 0. So it's basically just the OR gate completely flipped. The next gate we're going to be talking about is the exclusive OR. We'll go through the input. So if input A is 0, input B is 0, the output is 0. If input A is 0, input B is 1, the output will be 1. If input A is 1, if input B is 0, the output will be 1. If input A is 1, if input B is 1, the output will be 0. So it's called exclusive OR. It's basically an OR, only certain things are taken and not things. Alright, next gate. The next gate we're going to talk about is the exclusive NOR gate, or XNOR. So, if input A is 0, if input B is 0, the output will be 1. If input A is 0, input B is 1, the output will be 0. If input A is 1, input B is 0, the output will be 0. If input A is 1, input B is 1, the output will be 1. That's the last gate. Hope you learned something about logic gates today. If you did, please give me a like. That way I know I'm making the right content. Thank you very much for watching, and I'll see you next time.